Welcome back to the another video, guys. So in this video I'm solving section B with question 11. So let's get started with the video. So in this one we are going to talk about machine learning concepts, and the question 11 is about feature engineering, where sometimes raw data ain't enough. If you are giving a model just a timestamp, it might not learn much, but if you use a timestamp to calculate a new column and called it as a day of the week, suddenly the model can predict the sales of the week instance. There, you are building better inputs. So, transforming raw variables into more informative ones is called feature engineering. Question 12 asks about prediction types. If you want to know if email is spam or not spam, that's a category. But what if you are what if you are predicting a specific number like house prices? So there, when the output is continuous number that can go up or down, we need a specific type of algorithm designed for maths, not categories. So predicting a numeric value such as salary is an example of regression. Question number 13. So here I want you to imagine a student who memorizes the practice test answers instead of learning the math. They get 100% of the practice but fails the real exam. Model so here the models do this too. They memorize the training data so closely, including the noise and errors, that they can't handle anything they haven't seen before. So a model that fits training data perfectly but fails or on the new data suffers the overfitting. So this is the very clever example of overfitting by everybody. Question number 14 is the fix for that student who fails after memorizing all the things. So how do we stop this model from memorizing everything? We need to make the test harder or force it to ignore small details. We apply penalties during training that forces the model to keep its logic simple and flexible rather than complex or rigid. Dropout and weight penalties are examples of regularization methods. So I hope that student gets justice now and he is now a smart student. 15th question relies on the wisdom of the crowd. If you ask one expert a question, they might be biased. But if you ask 50 experts and take the majority vote, you are usually right. The machine learning we combine In machine learning, we combine the predictions of several different models to smooth out errors and get a better final answer. In training multiple diverse models to improve accuracy, this is what we called ensemble learning. Training multiple more diverse models to improve the accuracy of your data and models is ensemble learning. Question number 16. Imagine you built a super complex AI to predict the weather, but you need a check. Question number 16. Imagine you built a super complex AI that predicts weather. Before you celebrate, you just need to check that is it actually better than just guessing that it will be sunny every day or it's gonna rain every day. So you need a dumb simple model to compare against. If you are AI can't beat the simple guess, your AI ain't working. Let me read this once again. You need a dumb simple model to compare against. If your AI can't beat the simple guess, your AI can't isn't working properly, is not it showed you. So a simple reference model for comparison is called baseline model. So that dumb model is called baseline model. So now you know. So question number 17 is about core statistical rules. If you roll a dice, the result of the first roll doesn't change the second roll. They are independent events, right? So in machine learning, assume our data works the same way, that every data point is a fresh random sample from every same world. So independent unchanging data samples are described as IID, independent and identically distributed data. Question number 18 is about distinguishing between what the machine learns and what we decide. Question number 18 वापस से 219 पे 220 ठीक है. Question number 18 distinguishes between what the machine learns and what we decide. The machine learns the weight, but it can't decide its own learning speed or structure. These are settings that our data scientist has to tune manually before hitting the start button. Parameters tuned before training are called hyperparameters. Let me read this once again for you all. That the machine learns the weights, but it can't describe its own learning speed or structure. These are the settings that data scientist has to tune manually before hitting the start button. And this is what we call hyperparameters, where parameters tuned before training, that to actually distinguish between that what the machine learns and what we decide. The machine learns the weight, but it can't decide its own learning speed and structure. So hyperparameters comes in the role where the parameters is tuned before we train the model. Now comes the question 19, that is about A/B testing. So question 19, imagine Netflix wants to change their homepage. They can't just guess if the new design is better. They need a proof. They show the old design to a group A and now designed a new logo and then showed it to a group B. Then they compared the stat to see which one won. Comparing two versions statistically to see which performs better is called A/B testing. By the way, have you watched Stranger Things 5? Stranger Things, yeah, Netflix the case Stranger Things yaad aa gaya. So now question number 20. In this one, I want you to imagine a scenario where you have two columns, age and salary. Age is around 30 and the salary is around 50,000. The salary numbers are so huge that they can dominate the age number in the maths. So here we need to squash both columns down to the same playing field, where usually makes them both play around 0 and 1 scale. So this normalization typically rescales numerical features to the range of 0 and 1. And this is what we call scaling. That playground is 0 and 1. Now comes the turn for 21. Question 21 looks at a performance gap. If your model scores 99% in the practice but only 60% in the real world, the gap is huge, red flag. The gap tells us that the model is too sensitive to specific data it is trained on, but it varies too much. The difference between train and test performance measures model variance. Question number 22. Here I want you to imagine that you want to find an average height of people in the city, but you only measure people walking on a gym, walking off a gym, out of a gym. Your data is going to be skewed towards fit and healthy people because you are standing out of a gym and looking at fit people, but you are completely ignoring the people who are just roaming around in the city and they are obese and are this thin. So there comes a biasness in your data where you're just collecting data from a gym perspective where you are just looking at fit and healthy people. So this is a flaw in how you collect the data. You selected the wrong group, so your results are biased. Bias sampling is data collection. Bias sampling in data collection can cause selection bias. This is called selection bias, where you are just putting your whole focus onto the gym bros, not at the people who are not going to the gym. So what kind of analysis then you are doing? You have to collect the data of whole population from the city, who goes to the gym, who don't goes to the gym, and then compare and do an analysis. But this is completely wrong if you are comparing gym bros to the other ones. So, or if you are just collecting data from the gym bros. Question number 23, static models. So some models are like a printed book. You write it, print it, and it stays that way forever. Even if the world changes, the book remains the same. So these models are trained once on historical data and pushed to production. They don't learn anything new unless you manually update them, but they remain the same as they were before. A model trained once and not updated further is a static model. Means the model is in Purane Zamane. Now comes question 24. Now the question 24 is opposite. Think of the TikTok algorithm. It changes constantly based on what you liked 5 minutes ago. These models are constantly ingesting new data and uploading their rules in real time. Like if you like now in Instagram, if you like the meme that is related to a silly friend or a kitten, the algorithm puts updates on the algorithm, and and it will only show you cat videos and funny videos that you just liked and very similar kind of a video that you just like. So a model that continuously retain with new data is dynamic data that continuously changes. So this thing will be a very nice thing to keep in your mind where ठीक है. Now this thing will going to be in my mind for so long. अभी वो ऐसी रही. I think so. Question number 25, the last one. Cross entropy. So if a model says it is 99% sure an image is a dog, but it's actually a cat, that is a huge mistake, right? So we need a way to punish that confidence. That how can you say that it's a cat? Look at it, it's a dog. So you need to punish that confidence. We need a specific math formula that calculates the distance between a prediction and the truth, applying a heavy penalty before being confident and wrong. The loss function measuring divergence between predictions and the true possibilities is cross entropy. So that's it from my side. I hope you liked this video. Thank you for watching this video. Bye bye.